Hello students, myself Kale S.L, रयत शिक्षण संस्था RBNB कॉलेज रामपुर. 11 Science Mathematics Part 2 Lecture number 3rd Chapter number 1st Complex Number Exercise 1.1. In the previous video lecture we have completed here question 1 to 4 and the basic concept of complex number. We know the basic concept as powers of I. It is very important, powers of I is equal to under root of minus 1. We know here I is equal to under root of minus 1. Then its second power, that is I square, is equal to minus 1. I to the power 3 is equal to minus I, and I to the power 4 is equal to plus 1. So we have to remember the powers of I. Also a plus ib is a complex number, a plus ib, or we may write it as a plus bi also. Both are same, a plus ib or a plus bi, where a and b, these are the real numbers and I is imaginary unit, that is I is equal to under root of minus 1. So this is the real part, a is the real part, b is the imaginary part. We have seen this. When we add here real number and imaginary number, we add real number and imaginary number, we get the complex number. So now we start here exercise 1.1 and the next question, question number 5. So let us try to solve question number 5. Show that minus 1 plus root 3i to the power 3 is a real number. So solution of this, consider minus 1 plus root 3i to the power 3. Now here we have to use the formula a plus b bracket cube. We know this formula. This is equal to a cube plus 3a square b plus 3ab square plus b cube. We have learned this formula in school. And now here we take a as a minus 1 and b as a root 3i. So this is equal to minus 1 to the power 3 plus 3a square means minus 1 square into b means root 3i plus 3, then a is here minus 1 and b square, that is root 3i square plus b cube, b is here root 3i and its cube. So it is equal to, now minus 1 to the power 3, it is minus 1 plus here minus 1 square is positive 1 into 3. So it is 3 and this root 3i. Then here this 3 into minus 1, that is minus 3. Now here root 3 square is 3 and I square plus here root 3 cube means here root 3 cube means root 3 into root 3 into root 3. This root 3 into root 3, that is 3 into this root 3. So root 3 cube is 3 into root 3 into I cube. So this is equal to minus 1 plus this 3 root 3i as it is. Now here 3 3's are 9, so minus 9 and I square is minus 1. We know here I square is minus 1 plus here 3 and root 3 as it is, 3 into root 3 and I cube we know it is minus I, so here it is minus I. So we get here minus 1 plus 3 root 3i. Now this minus and minus become plus, 9 into 1, that is 9, and here plus into minus, that is minus. So 3 into root 3 into I. Now see here, this plus 3 root 3i and this minus 3 root 3i get cancelled, it becomes 0. Now here minus 1 plus 9, that is 9 minus 1, 9 minus 1, it is 8, and 8 is a real number, it is, or we may write here which is real number, because here we have to show this as a real number, means its expansion does not contain I, that is imaginary number. So here there is no I and only 8 is present here, so it is a real number, and therefore lastly we write conclusion, therefore minus 1 plus root 3I to the power 3 is a real number. In this way we have completed this question number 5. Now next question number 6. Question number 6 here, find the value of three plus 2 upon I into I to the power 6 minus I to the power 7 into 1 plus I to the power 11. 1 plus I to the power 11. We have to find the value of this. So solution of this, consider let 3 plus 2 upon I into I to the power 6 minus I to the power 7 into 1 plus I to the power 11. Now we solve firstly these two brackets. We take the product of these two brackets. Now here I to the power 6, I to the power 7, here I to the power 11. We know the powers of I up to 4. I to the power 1, that is root of minus 1, I square minus 1, I cube minus I to the power 4, 1. So what about the powers greater than 4? When the power is greater than 4, divide that number by 4. We divide that number by 4, just like suppose 6. Here 6 divided by 4. So 4 ones are 4. 4 ones are 4. So 6 minus 4, 2. So 2 is here remainder. So we write here this 3 plus 2 upon I as it is, and we write here I to the power 6 as I to the power. Here we divide by 1, so I to the power 4. I to the power 4 into I to the power 2. We have to must know what is the remainder. We have to find the remainder. We adjust the powers of I, multiple of 4. Here I to the power 4 is 1. I to the power 4 to the power 2, that is also 1. That means I to the power 8. I to the power 8, that is 1. I to the power 12, that is I to the power 4 to the power 3, it is also 1. I to the power 16, that is equal to I to the power 4 to the power 4, that is also 1. So we make the powers of I in terms of multiples of 4. Get it? And write the remainder as a separate power of I. So we write here power 6 as I to the power 4 into I to the power 2, so that we get 4 plus 2 as a 6. Similarly here I to the power, here we write I to the power 4 into I to the power 3, 4 plus 3, 7. We complete this bracket. Then 1 plus I to the power, here we write I to the power 11 multiple of 4 near to 11 and less than 11. Here I to the power 4, I to the power 8, I to the power 12. We cannot take I to the power 12. We take I to the power 8. So we write here I to the power 8 into I to the power 8 plus 3, 11, like this. So it is equal to 3 plus 2 upon I into I to the power 4. We know it is 1. I to the power 4 is 1. So 1 into I square, and I square is minus 1. Plus here, minus I to the power 4 is 1. I to the power 3 we know I to the power 3 is minus I. So here it is minus I. Complete this bracket. 1 plus I to the power 8, it is 1. I to the power 8, 1. I to the power 3, it is minus I. Complete this bracket. And so we get here 3 plus 2 upon I in bracket this minus 1 and this minus and minus plus, so plus I, minus 1 plus I. Now here this 1 and here plus and minus minus I, minus I. So we get here I to the power 4 I square minus 1, this minus sign as it is, I to the power 4 1 I cube minus I 1 plus I to the power 8 1 and I to the power 3 minus I. Now we take the multiplication of these two brackets. So we get here 3 plus 2 upon I, 3 plus 2 upon I into this minus 1 into 1, that is minus 1, minus 1 into minus I, that is plus I. Now multiply by I into 1 plus I and plus I into minus I, that is minus I square. Get it? We multiply by this minus 1 to this bracket and then plus I to same bracket. And so we get here 3 plus 2 upon I into this minus 1 as it is, plus I plus 2I, and here minus, and this I square is minus 1. Get it? Now this minus 1 into minus 1, that is plus 1, and this minus 1 get cancelled to each other. So here remains 2I. So we get here, so it is equal to 3 plus 2 upon I into 2I into this 2I. Now multiply by 2I inside the bracket. So we get 3 into 2, that is 6 into I, 6I, plus here 2 2s are 4, 2 2s are 4, and this I and I get cancelled to each other. So the solution is here 4 plus 6I. This is the final solution. So we get the value as 4 plus 6I. We may write here hence 3 plus 2 upon I into I to the power 6 minus I to the power 7 into 1 plus I to the power 11 is equal to 4 plus 6I. We write real number firstly and then imaginary number. Here 6I plus 4 we write firstly 4 and then 6I. So this is the solution. Now here next question number 7. In question number 7 there are so many problems. I think there are 8 problems. Evaluate the following. Question number 7. Evaluate the following. Means we have to find the value. We have to find here the value. First here I to the power 35. I to the power 35. That means here we have to find all the problems of powers of I, and power is more than 4. Now we have to make this power as a multiple of 4 and write the remainder as a separate power of I. So solution of this, we write I to the power 35, it is equal to I to the power, we know the table of 4, 4 8s are 32. So I to the power 4 to the power 8, 4 8s are 32. 32 and how much? 35, 33, 34, 35. That means 3 is the remainder. So we write here I to the power 3 separately. Get it? If we divide here 35 by 4 suppose. So 4 8s are 32. 4 8s are 32. And here 35 minus 32, that is 3. 3 is the remainder. So we write here I to the power 4 to the power 8. 4 8s are 32. And this remainder we write separately I to the power 3. For every problem we use this method. Now we know that I to the power 4 is 1. 1 to the power 8. And I cube we know minus I. I cube is minus I. 1 to the power 8 is 1 into minus I, and so the solution is here minus I. This is the value. Now next, second one is I to the power 888. So solution of this, we write this I to the power 888, it is equal to I to the power 4. Firstly write down by 4 and divide by 4. 4 2s are 8, 4 2s are 8, 4 2s are 8. There is no remainder. So here we know that I to the power 4 is 1. So 1 to the power 2, 2, 2. 1 to the power anything, maybe 0, maybe positive, maybe negative, it is 1. So it is 1. Now next, third problem here, I to the power 93. I to the power 93. Solution, I to the power 93 is equal to, I to the power 93 is equal to, firstly write down I to the power 4 and divide by 4 to this number. 4 2s are 8. Now 1 here and this 3 become 13. So 4 3s are 12. 4 3s are 12. So 1 is the remainder. So we write here I to the power 1. I to the power 1. So there is no need to write here power as 1. Get it? And now here I to the power 4 is 1. So 1 to the power 23 into I, and 1 to the power anything that is equal to 1 into I. So it is equal to I. In this way we get here I to the power 93 as I. Now fourth here, I to the power 116. Fourth problem. Fourth here, I to the power 116. So we write here I to the power 116 is equal to, write down here I to the power 4 and divide by 4 to this number. 4 1s are 4, 4 2s are 8, 4 2s are 8, 8 and 3, 3 11, and this 6 become 36, 4 9s are 36, 4 9s are 36, so there is no remainder here 0. So here we get now I to the power 4 as a 1 to the power 29, 1 to the power anything that is equal to 1, so the value is 1. Now fifth here, fifth, I to the power 403, I to the power 403. So solution of this, I to the power 403, it is equal to, firstly write down I to the power 4, 4 1s are 4, 0, and here also 0. Because we know that 4 into 100 that is equal to 400, and 3 is the remainder. So write here I to the power 3 separately. And now here I to the power 4 1, 1 to the power 100, I to the power 3 we know it is minus I. And so here 1 to the power 100 is 1 into this minus I. 1 into minus I, that is equal to minus I. So the value is minus I. Next, sixth problem, 1 upon I to the power 58. 1 upon I to the power 58. This is the sixth problem. Solution. So 1 upon I to the power 58, it is equal to 1 upon I to the power 4 and divide by 4. 4 1s are 4, 1 and this 8, 18, and 4 4s are 16, 16 and 2 18, so I to the power 2, I to the power 2. Now see here again, I to the power 4, 4 1s are 4, and here 1, 8, and 4 4s are here 4, 4 4s are 16, 4 4s are 16, and 17 and 18, here remainder is 2, I to the power 2. So it is equal to 1 upon, here I to the power 4 is 1, so 1 to the power 14, and I square we know it is minus 1. So here 1 upon 1 to the power 14, it is 1 into minus 1. So it is equal to 1 upon 1 into minus 1 minus 1. So the solution is minus 1. So we get here 1 upon I to the power 58 as minus 1. Now next, 7th problem. I to the power minus 888. I to the power minus 888. So solution of this I to the power minus 888, it is equal to, firstly write down I to the power 4 and divide by 4. Here minus sign, so minus sign. 4 to the 8, 4 to the 8, again 4 to the 8. And so it is equal to I to the power 4 is 1, 1 to the power minus 2, 2, 2. 1 to the power anything, positive number, negative number, 0, the value is 1. So the solution is 1. Now next and the last, 8th problem. 8. I to the power 30, I to the power 30 plus I to the power 40 plus I to the power 50 plus I to the power 60. Solution of this. Consider this problem, that is I to the power 30 plus I to the power 40 plus I to the power 50 plus I to the power 60. So it is equal to I to the power 4. Firstly write down I to the power 4 and count the table of 4. 4 sevens are 28. 4 sevens are 28 and 2 30. So 2 is the remainder. So I square. Remainder, write the separate power of I. Now here plus I to the power 4 and we know that 4 tens are 40. Plus here I to the power 4 and here 4 ones are 4. Then 1 and 10. 4 twos are 8 and plus 2 10. So I square. 2 is the remainder. See here. 12 4s are 48 and plus 2, that is 50. So here I to the power 4 and we write here 4 ones are 4, here 2 and 0, 4 5s are 20, 15 4s are 60. Get it? So it is equal to, now here I to the power 4 we know it is 1. So 1 to the power 7, 1 to the power 7, I square is minus 1 plus I to the power 4 is 1, 1 to the power 10. Plus I to the power 4 1, 1 to the power 12 into I square is minus 1 plus I to the power 4 is 1 to the power 15. I to the power 7 1, 1 into minus 1, that is minus 1 plus 1 to the power 10 1 plus here 1 to the power 12 1 into minus 1, that is minus 1. So here minus 1 and plus 1 to the power 15, that is 1. Now this minus 1 and plus 1 become 0. Minus 1 plus 1 get cancelled, become 0. So solution value is 0. So in this way here we have completed question number 7. Now question number 8. Question number show that 1 plus I to the power 10, 1 plus I to the power 10 plus I to the power 20 plus I to the power 30 is a real number. Is a real number. We have to show that this is a real number, means it does not contain I, that is a imaginary number. We have to cancel out I from this problem. So solution of this, let 1 plus I to the power 10 plus I to the power 20 plus I to the power 30. Higher powers of I here given. So it is equal to, we write this one as 1 plus I to the power 10, we write I to the power 4 to the power 2, 4 2s are 8, 8 plus 2, 2 is the remainder. So we write this 10 as 8 plus 2. Get it? Now here I to the power 20, I to the power 4 to the power 5, 4 5s are 20. Plus here I to the power 4 to the power 7, 4 7s are 28 and 230, so I to the power 2. So we get here 1 plus, now I to the power 4 is 1, so 1 to the power 2, I square is minus 1. Here I to the power 4, 1 to the power 5, plus I to the power 4 is 1 to the power 7, and I square is minus 1. So it is equal to 1 plus 1 square is 1, 1 into minus 1, minus 1. Here 1 square is 1, and this plus and minus become minus 1. So here it is minus 1. Now plus 1 to the power 5 is 1. Now here plus and this minus, so minus 1 to the power 7, 1 into 1, that is 1. Now here 1 and minus 1 get cancelled, here also plus 1 and minus 1 get cancelled. It is equal to 0. It does not contain I. So it is a real number. Which is a real number? Which is a real number. And therefore we write here 1 plus I to the power 10 plus I to the power 20 plus I to the power 30 is a real number. Therefore 1 plus I to the power 10 plus I to the power 20 plus I to the power 30 is a real number. In this way we get the solution of 8th problem. Now we see here 9th problem. Find the value of 9th problem. Find the value of I to the power 49 plus I to the power 68 plus I to the power 89 plus I to the power 110. We have to find the value of this. So solution of this. Consider I to the power 49 plus I to the power 68 plus I to the power 89 and plus I to the power 110. So it is equal to, we write this as, firstly write I to the power 4 divide by 4 to this number. So 4 1s are 4, 4 2s are 8 and 1 is the remainder. So we write it as I to the power 1. I to the power 1, there is no need to write here 1, power as 1. Plus here I to the power 4, we have to divide to this 68. Now here 4 1s are 4. 6 minus 4 2 and this 8 become 28. 4 7s are 28. So 4 to the power 17. Plus here we write this I to the power 89 as I to the power 4 and divide this 89 by 4. So 4 2s are 8. Again here 4 2s are 8. 1 is the remainder. So here we write I to the power 1. Plus here I to the power 4 and divide this 110 by 4. 4 1s are 4, 4 2s are 8. 4 2s are 8. 8 and 3 11 and this 0 30. 4 7s are 28. 28 and 2 30. So 2 is the remainder. Write that separate I to the power 2. And so here I to the power 4 is 1, 1 to the power 12 into I, this I. Plus here I to the power 4, 1 to the power 17. Plus here I to the power 4, 1 to the power 22 into I. And plus here I to the power 4, 1 to the power 27. I square is here minus 1. I square is minus 1. So I to the power 12, it is 1, 1 into I, that is equal to I. Plus here 1 to the power 17, it is 1. Here 1 to the power 22, 1 into I plus, that is plus I. And here 1 to the power 27, it is 1 and into minus 1, that is minus 1. So here minus 1. This plus 1 and minus 1 get cancelled. And now here I plus I, it is equal to 2I. So the value is here 2I. Value for this problem is 2I. So we again write here conclusion. Hence Hence, I to the power 49 plus I to the power 68 plus I to the power 89 plus I to the power 110 is equal to 2I. Now here 10th problem. In 9 there are two problems here. This is the first problem, and in question number 9 there is second problem. So we solve now second problem. Question 9 as it is second problem. We have to find the value of I plus I square plus I cube plus I to the power 4. We have to find the value of this. Question number 9 is find the value of. So solution of this, let I plus I square plus I cube plus I to the power 4, and all powers we have seen. This is the basic part. So put I as it is. I square we know it is minus 1 plus I cube is minus I, and plus I to the power 4 is 1. So here it is I plus minus, that is minus 1, here minus I, and here plus 1. This plus I and minus I get cancelled, minus 1 and plus 1 get cancelled, so the value is 0. Hence, again write here conclusion, hence I plus I square plus I cube plus I to the power 4 is equal to 0. Now here we have completed question 9. Now question number 10, simplify. Question number 10, simplify. I to the power 592, I to the power 592 plus I to the power 590 plus I to the power 588 plus I to the power 586 plus I to the power 584 divided by I to the power 582, I to the power 582 plus I to the power 580 plus I to the power 578 plus I to the power 576 plus I to the power 574. We have to simplify this, means we have to find the value of this. So solution of this, consider, let I to the power 592 plus I to the power 590 plus I to the power 588 plus I to the power 586 plus I to the power 584 divided by I to the power 582 plus I to the power 580 plus I to the power 578 plus I to the power 576 plus I to the power 574. Observe here numerator. In the numerator, here the powers of I decrease by 2. 92, 90, 88, 86, 84. Here also 82, 80. Here in the denominator, power decrease by 2. So the lower power of I in the numerator is I to the power 584. So we take here I to the power 584 common. So we write here I to the power 584 common. In the bracket, if we take I to the power 584 common from this 592, so we get I to the power 84 and how much number we add, and then we get 92, 6 and then plus 2, that is 8. I to the power 8 here. 8 and 84, that is 92. Plus here, now decrease by power 2. I to the power here 6, I to the power here 4, I to the power here 2, and plus here 1. We take this common, so here 1. Similarly, in the denominator, take here lower power of I, that is I to the power 574. I to the power 574 common. In the bracket, here 574 plus 8, that is 582. So it is I to the power 8 plus 574 plus 6, that is 580. So it is I to the power 6. Similarly here I to the power 4, here I to the power 2, and lastly here we put 1 because we take this as a common. Now observe here, this bracket and this bracket is same. So we cancel this bracket. We cancel this bracket. Or if we solve this I to the power 8 and this I to the power 6, I to the power 4, I to the power 2 plus 1, whatever may be the value, same value of this. So cancel this without calculating, because it is in the multiplication, we cancel it. And now here it is equal to I to the power 584, and shift this power to numerator using the rule of indices. It becomes minus 574. Get it? So it is equal to I to the power 4 minus 4, that is 0. Then 8 minus 7, it is 1, and 5 minus 5, 0. So I to the power 10. And now here we write I to the power 10 as I to the power 4 to the power 2, 4 2s are 8, and remainder is 2, so I square. I to the power 4 is 1. So it is equal to 1, 1 to the power 2, and I square is minus 1. 1 square is 1, 1 into minus 1, that is equal to minus 1. Hence the value of this problem is minus 1. So in this way we get here the solution of the 10th problem. So we have completed in question number in exercise 1.1. we have completed totally 10 questions, and the remaining problems from 11 to 24 we will see in the next video lecture. There are totally 24 questions in this exercise. So we stop here. Thank you.